Hi everyone, this is Mrs. J, and today we're going to talk about mutually exclusive and overlapping events. All right, let's start by talking about mutually exclusive events, which are events that cannot both occur in the same trial of an experiment. For example, if your experiment is flipping a coin and the two events are getting a head or getting a tail, so let's call this event A and let's call this event A, we would say that events A and B are mutually exclusive because there's no possible way to get both a heads and a tails. So if you made a Venn diagram of all of your possible outcomes, it would either be heads or tails. You would never see any overlap of the two. So the way you find the probability of two things that are mutually exclusive, so the probability of event A or event B happening, is simply finding the probability of event A happening and then adding it to the probability of event B. So if you have an OR problem, we're going to add up the two individual probabilities. Let's look at this first example together. So we have a dodecahedron dice, which is a 12-sided dice that we're rolling. So it has the numbers 1 through 12 on them. So we have 12 possible options for what we could roll. What is the probability that you roll and get an even number or a 7? So you can see that these two events, let's call the even number event A, and let's call rolling a 7 event B. These are mutually exclusive because it's impossible for a number to be both even and 7. So if we want to find the probability of rolling a dice that is even or 7, we're going to find the individual probabilities and add it up. So we're going to find P of A or B by doing the probability of event A plus the probability of event B. So in this case, well, the probability of rolling an even number, there are 12 possible options and there are 6 even numbers, so 6 over 12. And then the probability of rolling a 7, well, there's one possible 7, so there's one favorable outcome there, but 12 possible outcomes. So if you add those up, we get 7 over 12. So now we're going to talk about overlapping events, which are sometimes called inclusive events. So overlapping events are events that have one or more outcomes in common. So there can be times where both of the outcomes occur at the same time. So for example, if you're drawing a random card from a standard deck, if you're drawing a red card or drawing a face card, let's call the red card event A and the face card event B, there are going to be times when you draw a card that is both red and a face card. So there are some events that are overlapping. So these two events are not mutually exclusive. So if events A and B are overlapping events, the way that you can find the probability of one or the other happening is by, again, finding the individual probabilities, but then subtracting the probability of both happening. So the reason why we need to subtract away the probability of both is when we find the probability of event A happening, it would be all 3 of these outcomes, right? And if you're finding the probability of event B happening, it's all 3 of these outcomes. So you can see if I just add those up, I'm double counting these 2 outcomes that work for both. So we would have to subtract them away one time, so we're not double counting them, because really we just want to count all 4 of them. But if we do the 3 plus 3, we're counting 6. So again, you have to subtract the overlap where they're both occurring to avoid that double counting situation. All right, let's give one of these a try together. So what is the probability that you roll a dodecahedron dice, again, the 12-sided dice, and the result is an even number or a number greater than 7? So let's call this event A and let's call this event B. So to find the probability of A or B, again, since there are some overlapping events because you can be both even and greater than 7, we have to find the individual probabilities And then we have to subtract the overlap, so where it's both A and B, to eliminate the double counting that occurs there. So let's start with the probability of a number being even. So that will be 6 out of 12. A number being greater than 7. So that's 8, 9, 10, 11, or 12. So that's 5 over 12. But then we have to subtract the even numbers that are greater than 7. So that would be 8, 10, and 12. So that's 3 over 12. So again, this takes away the 3 elements that were counted as both even and greater than 7. So we've eliminated the double counting, and so we get 8 over 12, which is 2 over 3. All right, so here's one for you to try on your own, so please pause the video and hit play when you're ready to check. All right, go ahead and check your work here. So for example A, drawing a club and drawing a heart are mutually exclusive. There's no overlap in clubs and hearts, so you find their individual probabilities and add them up, so you get 1/2. But if your events are drawing a diamond or drawing a number card, those are overlapping events because there are cards that are both diamond and number cards. So you find the individual probabilities. So there's 13 diamonds in a set of cards, and there's 9 number cards per suit, so you do 9 times 4. So there's 36 number cards per deck. But then you have to subtract the ones that are the diamond number cards. So there's 9 of those, so you end up with a probability of 10 over 13. All right, so now we're going to try finding probability of these types of scenarios using what's called a two-way table of data. So you can see here we have some data about a school. So these students are categorized by grade and by gender, boy or girl. So you could see the columns, again, represent how many are in each grade, and the rows represent how many boys and girls there are. And the two-way tables kind of allow you to see the combinations of both of those categories. So here we're asked to find the probability that if you're randomly selecting someone from the school, that you select a senior or a girl. So here there will be overlap in students that are seniors and girls, because you can see here there are 108 seniors that are also girls. So we are going to be using our overlapping strategy. So let's call this event A and this is event B. So we're to find probability of A or B. We're going to find the probability that you would pick a senior first. So there are 202 seniors, and the total number of students is 808. Now we're going to find the probability that you would pick a girl. So if you go across the girl row, you can see that there are 412 girls in the school out of 808 students. And then again, we need to subtract the ones that are double counted. So 108 students have been counted as both seniors and girls, so we have to subtract that away to avoid the double counting. So here we get 506 over 808, which is 253 over 404 when you simplify. All right, let's try another one together. So here we're going to find the probability that it is the complement of being domestic or late. So remember, the complement is it not happening. So we're going to find the probability of it not being domestic or late. So we can actually, to find the probability of the complement, I'll say A or B complement. Remember, we could do 1 minus the probability of A or B. So if we're finding the probability of it not happening, we can find the probability of it happening and subtract it from 1. And again, we're calling domestic, I'll call that event A, and we'll call late event B. So for this one, notice that the total number of flights is 108, and they can be categorized as late or on time. So they could be categorized by their timeliness or where they're coming from, so domestic or international. So we see that there is some overlap in domestic and late. So that overlap would be right here. So these are not mutually exclusive. So we need to subtract away the stuff that is being double counted. So again, let's start by finding just the probability of A or B, and then we'll subtract it from 1 at the end to find the complement. Okay, let's start with the probability of event A, which is it being domestic. So if you look across the domestic row, there are 120 domestic flights out of 180 total flights. And now let's find the probability of the flight being late. So if you look down the late column, there are 18 late flights. And then we need to subtract away the overlap, the probability of A and B. So there are 12 late domestic flights. So 12 out of 180. So this gives us 126 over 180, which is a probability of 7 out of 10. But remember, we don't want to find the probability of it being domestic or late. We want to find the probability of it not being domestic or late because of the complement. So to find that, so A or B complement, we do 1 minus 7 over 10, which is 3 over 10. All right, here's this last one for you to try on your own. So again, please pause the video and give it a try. All right, go ahead and check here. So this is an overlapping event. So the probability of having a headache is 27 out of 100. The probability of not taking medicine is 40 out of 100, and there are 15 overlapping events where they received a headache and took no medicine. So you have to subtract that away, so you end up with a probability of 13 over 25. All right, that is all for today's video. Thank you for watching.